Hi guys, my name is Srinivas. Today we will going to talk about the popular distributed messaging tool called Kafka. So you might heard about a Kafka before, okay, or you might have seen some messaging brokers. So before we understand about what is Kafka and what is a messaging brokers and everything, we will just get started with okay, what is a messaging broker and why we need to learn about a messaging broker. So in the real world, you are getting the data from one system to another system. You are very fine. And why I need to use a messaging broker? If I don't use a messaging broker, what are the problems? And if I use a messaging brokers, what are the advantages? So what are the different types of messaging brokers and where Kafka will going to come into a picture? So today we will going to talk about that. So let's get started with our agenda today. So first of all, you should understand what is meant by a messaging broker. Okay, why we need a messaging broker. So let's get started this one. So a Kafka is a distributed messaging broker. So first you should understand what is a messaging broker. Lot of people, I have seen lot of questions like, sir, what is the differences between Kafka and Storm? And people will ask this kind of question. So because they lack of understanding what is a messaging broker and what is a processing engine. There are a lot of differences there between these two. So today we will going to differentiate it. What is a real-time injection tool and what is real-time processing tool. Okay, it's a real-time injection tool and this is called a real-time processing tool. So let's talk about these two things. Understand, right? Of course, our agenda is Kafka. We will concentrate on this and I will cover another video on this Storm. This is called real-time processing tool. Okay, fine. So let's get started with a real world example, not an IT example, it's a real world example, how you will see Kafka in which area it will going to fit. So that's what, before talking about a Kafka, I would like to name it as a messaging broker. If I don't have a messaging broker, what is the problem? So let's get started with a real world example. If you see any of my videos, we will get start with something called a real world example. So refer to the other videos of mine, so you can check out all the real world example for every framework. Let's get started. So let's get started with something called a local hotel. Okay, this is a local hotel and you have a high-end restaurant. So you will see a lot much differences in between this both, right? So let's get started. What is the big differences you will going to see in the local hotel and a big restaurant? Okay, understand, right? So this will going to let you understand where a messaging broker will fit. So if you see these two different kinds of hotels, both serves food only, but the services provided by the local hotel is different from a restaurant. So how would that happen? Let's say in this local hotel you have a kitchen. Okay, understand, right? So this is the kitchen and there will be one guy who will going to take your requirements and he will cook and he will going to give it back to that one. Understand, right? So let's take our users in this example. Let's say there are multiple users, okay, or multiple customers. So let's say Ravi comes right now and he pays money to the owner and he will go to the kitchen directly. And again the other guy Ramesh came here and he will pay something and he will directly go to the kitchen. And also Ravi, he also pays something, he will also directly go to the kitchen. So what is the problem here, right? You know, all three peoples came with a different orders. Okay, so this kitchen guy got a confusion. Oh, to whom I have to serve first? So if assume that you don't know who came first, the kitchen guy really don't know who came first. So what he will do, he will randomly pick that order and he will serve and he will give. So at that time the Ravi who came first got a problem. He will say, hey, he will hit this kitchen guy, hey, I came first, you didn't serve it to me first. Then this Ramesh will say, hey, he gave me, right, why you are shouting? Like that you will have a big collision here. Then there is a big problem at the kitchen guy. A kitchen guy will become a burden. He will going to say that, hey, come on, you are making me a pressure because you are hitting lot of data here. So customers will going to give a data at one rate and kitchen guy will going to take the data at another rate. I mean to say the speed you call it as, okay. So this is really a big problem in a local hotel. So in the local hotel, serving will be in a different manner because they don't follow any order. Here there is no order. Okay, I am talking about what is the need of messaging broker in the real world, why you need to maintain a queuing mechanism. Okay, if you go to any tickets collecting or any ATM line, you will follow some order, right? Who will come first, to them you will going to serve and you will going to give the request. So like that one, you need to maintain an order, but in this local hotel there is no order here. There was a big burden. In the real world, the applications also looks like this. So look at this here. Here how in the real world the looks like, Hadoop is like a kitchen guy, and this is like OLTP databases and web servers and applications. These all monitoring systems. These are all the different customers, like different applications which is pushing the data into a data lake. In the real world, you will be seeing Hadoop is a data lake which will be collecting the data from a different applications. If all different applications pushes the data with a different rate, your Hadoop can't take the data. There will be a burden. Understand, right? So look at this. This is how the customers will going to see the world to the Hadoop. You don't have a unified messaging log system. This is the really a big problem with your multiple distributed models. You mean to say you have lot many applications which are trying to push the data to the Hadoop or any distributed model engine. So here you need a proper order, then only it will be a serve better. You got the point? So that is the problem. That is a real world problem. So that will be applied to your IT part also. In the IT also things will be like that, right? So if there are let's say there is some sales sector, okay, and they will be generating the data by logs or something in the real time, and there is something called marketing system, and there is like account system. So you have lot many accounting system. So you have lot many systems pushing the data to the Hadoop. So what will happen? There will be a burden at a Hadoop side. So the might be some performance will be degraded here in the distribution model side. Understand, right? Now how do we solve these problems? So how do you going to decouple? Because why there is a problem here, right? You have a direct interact with your application systems with the data lake systems. That is the problem here. How do you solve it? So try to solve your local hotel problem. Okay, so what they did, right? If you go to a restaurant, you will see that problem in a problem solution in an order. So we will going to apply that solution only to our applications as well. So you understand the problem. My question is, what is a messaging broker? Then we will talk about what is a Kafka. So where the Kafka will come into a picture in this distributed model. Okay, so still you got the problems, right? You understand the problem. So we will talk about Kafka little bit later. Okay, but first understand the problem. This is the problem. Look at this here. You will be having a lot many applications pushing the data to your different systems. So this got a messy. This is like this data got a messy kind of thing. You really don't want to end up your application to be messy like this. You don't know to whom you are sending the data, from where you are receiving the data. You don't going to see such kind of thing. So for this one you need a unified messaging log. So what is that log and how do we going to do it in our real world? Let's get started with that restaurant one. So now we have seen something called local hotel kind of thing. Now let's go to a restaurant. So if you go to a restaurant, what's going to observe? Where you have observed, what are the big difference you observe? Whenever you go there, in order to solve this problem, you already have a, look at this here, you already have a similar way of kitchen only. Understand, right? There is only one guy. Assume that there are one guy, but in a distribution model you will have a lot many kitchen guys. I will name everything in the Kafka. We will going to see the terminology as well in this video only. Okay, now let's hear. Whenever a customer, how do restaurant owner will solve it, right? He will say that, hey kitchen guy, don't take the orders as you like. I am placing something called a queue. This is an order queue. Understand, right? I am maintaining one queue. So who will write the data to the queue? So that's one. Let's hear. Now the kitchen guy will going to take the data from the queue and he will serve in that way how he received the data from the queue. So now the question is, who writes the data to the queue? So usually a customer will come, he won't talk with the kitchen guy directly. He will going to sit in his seat and in her seat. So look at this, they will come and sit. Now what you will do, you will hire one guy who who will receive the request from the customer. So that guy is called a bearer, right? So this guy is a bearer. He will go and he will take the order and he will write the orders into the queue. And then remember, a bearer won't collect all the requests or all the orders from all the clients and he won't place it in the order queue. If he do, that will become a batch. He will going to do, whenever he take order, he will going to pull that one into the queue. So whenever he take the order from this customer, he will go and pull into this queue. So now what is happening? The kitchen guy won't get any problem. See, the customers will generate the requests with one rate and kitchen will going to take the data from that another rate. So understand, right? You tightly decoupled this customers and the kitchen. So you maintained a order messaging queue. You have an order for the customer request and you will going to take from that and you will going to process that particular order from that queue. So this solves your messaging problem. Okay. So what is actually why you need a messaging thing, right? A messaging thing is really needed to solve your daily issues. Okay, look at this here. This is what a messaging, what it is doing, right? It is going to decoupling your subsystem. So here the messaging is something called a queue. So the guy who generates the messages into the queue is called producer and the guy who consumes the messages from the queue is called a subscribers. So in this our example, you can put down our Kafka terminology like this. Okay, so what you are doing, right? Look at this. In the real world applications also, what you will do, you will going to use, these are different applications like sales and marketing and accounting. So instead dumping into Hadoop directly, what you will do, you will be giving out some message broker. So this is called a unified log broker who will going to take the data and put it into a particular framework. So by this one, what you did, right? You have tightly decoupled the source and the target. You have tightly decoupled, so there won't be any problem at the Hadoop side because you will be pushing the data in a proper order. So this is what a broker, a messaging broker. So there are, in the real world applications, there are lot many brokers. Like there are a traditional way of messaging. Means traditional way of messaging means not Hadoop, into some other applications. Let's say in your real, you all understand this example, the hotel example. I will revisit this example when I talk about some terminologies in our Kafka. Okay, so I'll going to revisit this example, restaurant example. You understand right now, right? Okay, so here the guy who writes the data into the queue is called a producer and the guy who consumes the data from the queue is called a consumer. So that's what this one is called pub sub mechanism, publish and subscribe. Let's say you all know YouTube videos. When you subscribe something, some channel, when someone posts something into that channel, the people who got subscribed will be pop up with a note like, hey, you got a video. So that is what a real time injection. When someone publish something in their site, you will be getting out that particular video or any messages. Let's say in Facebook you have subscribed to Times of India. So what it will do, it will going to send a notifications whenever a new news got inserted into that particular Times of Indian website. So that is what like a publish subscribe mechanism. People who got subscribed to the channel will be getting the data which was published in that queue. So the guy who writes the data, that is called producer. I will come back to this one. Okay, so now let's keep and let me open the another note MS Paint. Okay, now look at this here. So that's what we understand what is a messaging broker. So but nowadays there are lot many messaging brokers like OpenMQ, RabbitMQ, JMS. Lot many messaging brokers are there, but they will going to message the data to a traditional systems. But we don't want a traditional systems. Nowadays everything is distributed. No one is using much a traditional way of storing the data. Now you have to message us to a distributed processing frameworks like Hadoop. So you need a distributed messaging tool. You can't use a traditional messaging tools like RabbitMQ, OpenMQ and all these things. So for this one you need a distributed messaging queue. There are lot many distributed messaging queues. So one of the which everyone uses is what called Flume. Flume is a one kind of a messaging tool, but there it is a purely developed by Cloudera. He made popular because everyone using a Cloudera vendor distribution model for their production environment. So he made mostly use of this injection tool. And but you know, there are some problems with this where that messages won't be replicated. I will tell you that one as well. And now this is was given by Cloudera, and you know, you all people uses something called Facebook. Whenever you click something in the Facebook, how would they know, how do a Facebook guy know that you have clicked something? If you see in a Facebook, when you see one particular product, let's say in Facebook you have accessed a Flipkart website, so when and you checked for a product, that Flipkart guy will say that hey, he is interested in that product, always push this kind of data to that user. So how would the Flume, how would a Facebook guy or how would a Flipkart guy knows that you are doing something in the Facebook, from the Facebook you did this, which means that Facebook will going to log everything what you are doing in the site, right? So there should be a locking mechanism, right? A distributed locking mechanism, that is called scribe. Facebook uses something called a scribe, okay, like that. Your LinkedIn is also a very big social media, official social media. So what you will going to use it in LinkedIn, they have created one tool. That tool is our concept today, that is called Kafka. So Kafka have lot many advantages over Flume. Flume is for one purpose and Kafka is one purpose. That is the reason there is another tool that is called Falca, which is a combination of Kafka and Flume. Okay, there is a one more framework kind of concept called Falca. So Flume sync will be the source producer, like that, or okay, so such kind of things will be there. That's what I'll tell you. I'll cover the differences between Flume and Kafka in the other video. Okay, so let's say here, this is what called a distributed messaging tool. So now we going to talk about something called a Kafka. Kafka by definition, okay, so let's go to normal definition. So this is what the Kafka symbol, and Kafka have a information like this. Okay, look at this, you can see that a Kafka is nothing but a distributed streaming platform. What does mean actually a distributed framework, right? Look at this, it will simply distribute the data. This is the official information that was posted on the Kafka website, official website. So it lets you publish and subscribe to the streams of records, and also it lets you store the stream of records in a fault tolerant way, and also it will process the records as they occur. So it will maintain an order, that's what it is talking about. Okay, and also it will going to maintain something called replications, which will going to give you a fault tolerant purpose. So a Kafka is a distributed messaging tool. Now in our restaurant example, if you see that there are some terminology you have to learn in Kafka. So there is what is meant by producer, what is meant by consumer, and what is meant by topic. These are the things you have to know, then only you will understand the total framework of a Kafka. So in our example, let's show you. So the guy who generates the data, okay, that is called a producer. But to understand properly, let me talk all these things. So let's talk about the terminology in the Kafka. So Kafka is you understand what Kafka will do. It's a distributed messaging tool, a real-time injection tool. When something happen in one application, it will log that one into a distributed model by decoupling your distributed applications with your application server. So you really don't going to have a burden on any of the things, and it can decouple the high injected application system with the low accepted systems, low rate accepted systems like your data lake kind of thing. So that's what it will decouple it very nicely. Okay, so let's see how the architecture goes like. The guy, first of all, you should know what is meant by a message. A message is nothing but a bytes of it's a bytes actually. So don't think that Kafka will do some kind of a transformations. Literally it can't. It will take everything message as a bytes. It won't process anything. It's a real-time injection system, not real-time processing system. It won't process anything. It will take everything as a byte. So a byte, a load of information is called as a message. So who will generate this message? That guy or the application who generates the message, that is called a producers. Sometimes if you attend to any interviews, people will ask you, have you written a custom producer in your Kafka? Means custom producer means you have to write your Java code or any Python code who will going to read the file and find out the latest records and pushes it out. Understand, right? Like that you have to write a custom producers. They will be asking out. There are predefined predefined producers coming with the Kafka as well, like console producers and all these things. So now the producer will going to generate the data, that is called a message, and that message will be stored in a queue, one queuing mechanism. That one is called broker. This is what called a broker, and the guy who subscribed to this broker will going to consume the data. Okay, these are called consumer. So in our example, the bearer is the producer who writes the data into our order queue, and the kitchen guy is the consumer who consumes the data from there and give it to the target applications like Hadoop or something. Okay, fine. Now let's say here there will be, as it is a distributed model, let's say if it is a very big hotel, you will have multiple producers. Agree? It's a distribution model, right? So you will have a multiple producers who will going to push the data into the broker. These are all called producers, not customers. And there also similarly you will have something called multiple consumers, multiple kitchen guys in that kitchen, in that restaurant, right? Like that. There will be a multiple consumers, there will be a multiple producers. Now the question is, how a consumer will going to take the data? That is the question. How do you identify uniquely a message? How do you organize the message in the broker? This is what the next topic, that is called topic only. Okay, understand it? So let's say how a message will be organized. Let's say the messages will be organized in a topics. If I don't have a topics, what is the problem? So let me tell you that problem. Let's say this consumer, let's say this kitchen guy will ask to the broker, hey, bring, he will only consume the data, so he will going to pull the data from the broker. Okay, this is a pulling mechanism. Okay, so this guy will say, hey, I want biryani. Everyone, he will say, hey, give me the biryani order. Now the broker will say, lot of producers, means this bearer also written biryani and this bearer also written something called biryani. So these producers will just go into a generate, these producers will going to put that order here as a biryani. So when a consumer asks, hey, I want biryani, now the broker will say, multiple producers are generating biryani, which producer biryani you want? This guy will going to take veg orders and this guy will take a non-veg orders. Okay, so the biryani is of two types, like veg. Okay, so you don't know, the consumer asks, give me biryani, then broker will say, I have multiple producers writing biryani, so which producers you want? When the consumer asks this one, the broker will say, which producer you want? Oh, I want to be a specific, right? Okay, let me say that, hey, I want, consumer will ask, I want the data produced by the producer called veg. So I want, you will going to mention producer name. Then the broker will say, hey, this producer is writing lot many orders, which order you want? So it won't remember biryani. Okay, you asked earlier biryani, now you say producer name. So it won't remember, it will say, hey, which guy have lot of orders like veg biryani and veg paneer and something. Okay, so you will going to say that order, but you know, you don't have a proper identification of the message. So to maintain an identification of message, your Kafka will going to put that one in a topics. So this is called a topic. So there will maintain two topics here, veg topic and non-veg topic, like in a queues. Okay, understand it? So the message will be organized in a topics. Got the point, right? So try to relate to our real world, how this framework. If we don't use that one, you should understand what is the problem. If you understand the problem, you will understand what is that particular solution. So to understand any framework, try to get started something like, if I don't learn this framework, what is the problem? If you know the problem, 80% of that one, what is that framework will going to answer. Okay, understand what is the problem first of all. I don't want to learn any new framework. Why should I learn? What is the problem with the existing things? You should know. Okay, so look at this here. That's what here. This framework will just going to solve that one by putting that messages into the topic. So this is a veg topic. Now this consumer will going to say that, hey, I want biryani from this topic, so it is a veg biryani. So automatically he will going to uniquely identify the message and he will going to got the data. You all understand, right? So understand the terminology called producer, the guy who generates a message. Broker is nothing but a collection of nodes where the topic will be distributed. Okay, I will tell you that one. And consumer is the guy who consumes the data from the topic. A topic is nothing but a unique way of organizing the message. The topic data will be divided into small parts that are called partitions, and the partitions will be distributed into the multiple machines. These partitions got distributed into the multiple machines. So you can have a look on this particular diagram where you will get a clear idea. So look at this here. Producer generates the data, and Kafka cluster contains multiple brokers, multiple machines, and the data was organized in a topics, and the consumers who got subscribed to Kafka cluster will be getting the data. As it is a distributed model, you will going to have a n number of these things. Is it clear, right everyone? You got the point? So this actually talks about all the internal things of a particular framework. So you can see that one in the example like this. Look at this here. Let's take a retail applications. A retail application generates the data from a different servers, and look at this one. So a retails will generate the data of a different producers will be there, and the data will be replicated in the Kafka cluster, and the consumer guys who were in the consumer group will register, takes the data and pushes into the data center. This is how actually distributed messaging will going to work. After you got the data, what you will do, the data is what? Processing. So if you going to use a real-time processing, what will going to happen, right? You don't need to maintain any intermediate storages like disks or something. So on live only you will process the data and you will going to perform some analytics. So that is called a real-time processing tool. That is called a real-time processing tool like Storm, Spark Streaming and Linq. If you want to know what is Storm, what is Spark Streaming, what is Linq, you can watch my further videos which got explained in a real world example like this only. So today we have used a restaurant example for our Kafka part. Okay, like that in the subsequent videos we will be talking about the real world example and we will attach to our framework. If I don't learn this framework, what is the problem? Okay, thanks guys. We will talk about more in Kafka in detail about the installations and running a live demo in the subsequent videos. Thanks for your time.